Okay, so here's the interesting shape you made. I guess we're sitting on the wrong side. I can rotate it around. Tell me what you were thinking when you were making this, and why you think this shape is so interesting.
Well, I just sort of wanted to change some variables around, but so first I sort of changed the values in these parts.
Inside the sine and cosines. Okay, yeah.
And then I changed one of them to a cosine times t. I changed one of the coefficients to a cosine, and then it made it really complicated.
Yeah, you changed one to something that had a cosine of cosine.
Yeah, it made it really complicated.
Yeah, that was actually pretty cool to see. It made it really complicated.
And then so I had to erase that, and then I tried adding a division symbol, but then when that happened, it sort of made all these straight lines because I was dividing by 0 some of the time.
Uh-huh.
So I just had to add something to it to cancel it out, and then it made this.
That was a neat shape.
Yep.
Do you notice is this shape as symmetric as the other one I put in?
No, it's not very. Maybe I think it's symmetric on this axis here.
Oh, interesting. Maybe it is.
But I think that's all it has.
You're right.
Right there.
It does look like it's symmetric. That's a great thing to notice. Okay, cool.
Yep.
So we'll scroll down to your shape here that you made. All right, tell me about what's going on here.
Well, I wanted to see what happened if I used irrational numbers.
Okay.
So I used pi times t and e times t for some of the values.
All right.
I ended up with this really, really complicated shape.
Yeah, what do you think's happening here?
Well, maybe it has something to do with the infinite decimals.
Okay.
But it's weird because there's definitely a pattern here. And it looks like they're looping in groups of 4.
Ah.
Like there's always 4 lines next to each other.
Okay. Yeah, that's a fascinating observation. Actually, I'll talk to you about that in a minute. Okay. Anything else you notice about your shape?
I think it's symmetrical.
Some of the lines intersect with each other, so they weave through each other.
Some of them do weave through each other. All right, so you notice that something's going in groups of 4. So I'm going to go back up to your brother's shape here. Just making sure it's on the screen. And I'm going to change it. I'm going from 50 pi to going, the t value going from 0 to 50 pi to go 0 to 500 pi. Okay. All right, and I'm going to run this, and let's see what happens.
So it looks like it sort of just filled in.
Okay. That actually surprised me a little bit. Okay, but you can still see the outline of the original shape there.
Yeah.
It looks kind of like a lot of lines.
Yeah. Okay, now I'm going to do the same thing down on yours. Actually, you know what? Let me change your shape, get rid of that division, and change it to a plus.
You might want to scroll up a little bit.
Okay. Sorry about that. So first, instead of that divide, I'm going to change it to a plus, and now we get that loop. Okay. All right, now I'm going to go to 500 pi. Let's see what happens here. Same issue. Okay.
Interesting.
All right, now I'm going to do the same thing down below. Yeah, you were noticing things looped in groups of 4. Let's run this for 500 pi. What do you see now?
Sort
A
of
giant
random.
mess.
Uh-huh.
It's sort of like spiky now. There's some sharp edges.
But it looks like it's a general shape. It's like a trapezoid.
Well, a 3-dimensional trapezoid.
Yeah. Trapezoid prism.
Yeah, so the interesting thing that's happening on your shape because of those irrational numbers, whereas on the first shape, and I actually don't know why this is fuzzing out. We'll go to 500 pi, but this is a closed loop, so it'll repeat.
Yeah.
Okay, and that's because the 2's 3.5, which is really just 7 halves. So 2, 7.5, 2, 5.
Yeah.
We'll be able to find a least common multiple, and the thing will repeat. But the problem we've got down here
They never have a least common multiple.
is you've got pi's and e's.
So this will never repeat?
This will never repeat, and this becomes what's called a space-filling curve. So you will probably hit every single point inside of this shape, and the x value for cosine goes from -1 to 1. This one, sine plus cosine, looks like it goes from -2 to 2. Sine of t plus cosine of e to the t. And the z value goes from -1 to 1. So there's your trapezoid. That's actually pretty fun. We will not be 3D printing this monstrosity. Because we could just make a block. That was neat. It's neat to play around with, and I wanted you to have an opportunity to see some of the interesting shapes you can make with sines and cosines rather than just seeing that they're parts of triangles.
Yeah.
All right. Good work, guys.